Okay, let's continue step 2. So if we look at this new augmented matrix, the coefficient matrix is in strict triangular form, and we can rewrite it as a linear system. So that is the first one. Okay, second equation will be minus 7x2 minus 6x3 equals minus 10, and then the last equation becomes minus 1 over 7 x3 equals minus 4 over 7. Back substitution, right? We can solve x3 equals 4 and then go back solve x2 and then go back solve x1, right? So we will get the solution is the same, of course. The solution is 3 minus 2 4. Okay, so now with the augmented matrix, okay, with the augmented matrix, we choose the pivot row and the pivot, right? We replace the row with using the row operations, right? We are using the row operations, and we replace row 2 and row 3 by its sum with the multiple of another row. That's why here, okay, that's why here, if we are going to replace row 3, we are not going to multiple 7. Okay, we are not going to multiple 7 based on row 3, because we will keep this row and we do the constant multiple in the pivot row. Okay, pivot row and pivot. Okay, and try to write this augmented matrix in the corresponding system. Okay, come back to the system, then we can use the back substitution to solve it. Okay, to solve it. And to those row operations are not unique. Okay, those row operations are not unique. For example, here, as I said, if you don't want multiple 1 over 7, if you don't like the fraction 1 over 7, you can interchange row 2 and row 3. Interchange two rows are also row operations, right? Interchange two rows, and then you can multiple for this is new row 2, you can multiple by 7 to make this minus 1 over 7 becomes 0, and then you get another strict triangle form, and when you solve it, it's the same solution. Okay, it's the same solution. You can transform it in another equivalent system. Okay, but the solution is the same. Okay, solution is the same. Now let's looking at this system. Okay, here should be 0. Okay, here should be 0. So let's finish this system. Okay, let's finish this one. Solve the system. Okay, solve this 4 by 4 system. We have 4 equations and 4 unknowns, right? 4 unknowns. So the first step is trying to write the augmented matrix, right? Augmented matrix. We are going to use the row operations based on the augmented matrix to reach a strict triangular form, and then using the back substitution. Augmented matrix. Now the first one is 0. Okay, 0. The first term is 0, and then minus 1, minus 1, 1, 0. Second one, 1, 1, 1, 1, 6, 2, 4, 1, minus 2, minus 1, 3, 1, minus 2, 2, 3, right? So here, if you decided the first row is the pivot row, and this coefficient for x1 is pivot, that would be a problem. How can you make those coefficients for x1 as 0? Because this is 0. If you multiply any number, it's still 0. How can you make this coefficient becomes 0? We cannot cancel out those coefficient for x1. Everyone is clear? So step 1, we will interchange, okay? We will interchange row 1 and row 2. Why we change row 1 and row 2? Because this coefficient for A11 is 1, right? For x1 is 1. We like the pivot is 1, right? Is 1. Then we don't need to multiple a fraction usually. So step 1, I will write the row operation, okay? Interchange row 1 and row 2. Interchange row 1 and row 2, then we obtain the new augmented matrix. So that is 1, 1, 1, 1, 6. Second row becomes 0, minus 1, minus 1, 1, 0. Then the third and fourth are the same. 3, 1, minus 2, 2, 3, right? So that is the easy row operation, interchange to row. Then we can decide it, okay? Then we can decide the pivot row and pivot. So the first row is the pivot row. And then the first one, this A11 is 1, right? So for the second row, this coefficient of x1 is already 0. So we are not going to perform, we are not going to do any row operations for second row. It's already 0. Now we need to replace row 3 by row 3 minus 2 times row 1. And we are going to replace this row when this row minus row 1 multiplied by 3, right? So that is the row operation in the second step, okay? That is the row operation in the second step. Now let me write it, okay? Let me write it. Step 2. So we are talking about the previous, okay? The previous. Step 2 is based on the augmented matrix in the first step. So we will do replace row 3, okay? Row 3 minus 2 times row 1. And then row 4 minus 3 times row 1, okay? And of course, we will keep the pivot row, okay? Pivot row. So let me write this new augmented matrix. 1, 1, 1, 1, 6. And since the second row coefficient for x1 is 0, so that's 0. And we keep this row. No row operations will be made. And then third row, and let's replace the third row. So I will still do the green color, okay? Green color. So we multiply by 2 for the first row. We get 2, 2, 2, 2, 12, right? Multiply by 2, right? Multiply by 2. Then that will be the third row here. The third row minus the green numbers, okay? The third row minus the green number. 2 minus 2, 0. 4 minus 2, 2. 1 minus 2, minus 1. Minus 2 minus 2, minus 4, right? Minus 4. And then minus 1 minus 12. Minus 13, right? Minus 13. So far it's good. If you made a mistake on any one number, then your solution will be wrong. Okay, so be careful. Okay, be careful of each simple calculation. If you mess up any one entry in the matrix, then it's totally wrong. Okay, it's totally wrong. Then let me mark in yellow. So the first row times 3, so you get 3, 3, 3, 3, and 18, right? 18. So that is in green color. So that will be row 4 minus those yellow numbers to replace row 4. 3 minus 3, 0. 1 minus 3, minus 2. Minus 2 minus 3, minus 5. 2 minus 3, minus 1. 3 minus 18, minus 15. Right? Everyone's clear? So this is the new augmented matrix after step 2. Okay, after step 2. Now what is the next pivot row and pivot we are going to choose? We are trying to get close to the strict triangle form. So we are going to make the coefficient for x2 here. In the third and fourth row, those becomes 0, right? Those becomes 0. So the second row will be the pivot row, right? The second row will be the pivot row. So pivot row, let me write here. And this minus 1, this number will be pivot, right? This number is pivot. So it's also easy, right? So we are going to replace the new row 3, when row 3 plus row 2 multiplied by 2. And row 4 will be replaced by row 4 minus row 2 times 2. Everyone is clear? So let me write the row operations, okay, in step 3. So we can make those coefficient for x2. This is a32. This coefficient is a32. a42 becomes 0. So step 3, okay? Step 3. What is the row operations? Row 3, okay? Row 3, it's based on this above matrix, augmented matrix. Plus 2 times row 2. And then row 4 minus 2 times row 2, right? And then I'm going to write the matrix here, continue here. So I will keep the first and the second row, right? I will keep the first and the second row. We are not going to do anything with the first row because of the strict triangle form. And 0 minus 1 minus 1, 1, 0. So I will use green color again. So you need to do this part by yourself. Okay, you need to do those in your mind. So second row times 2. So we still get 0 minus 2 minus 2 2. We can select every row as pivot. It's one by one. Okay, it's one by one. What do you mean every row as pivot? Sound is low. Each step, each row operation, you can only choose one row. You can only choose one row as pivot row. And as I said before, for the first one, that is your original augmented matrix. But you cannot choose the first row as your pivot row because this A11 is 0. You cannot eliminate A21, A31, A41 as 0 when you choose 0 as a pivot, right? Because 0 multiple any constant, you still get 0. How can you cancel those? It's impossible. That's why we interchange row 1 and row 2 to decide the appropriate pivot, right? Pivot. Now, here is third row will be replaced. 0 plus 0, 0. 2 plus minus 2, 0. Minus 1 plus minus 2. Minus 1 plus minus 2, minus 3. Minus 4 plus 2, minus 2. Minus 13 plus 0, minus 13, right? Minus 13. That is the third row, new third row. And then row 4, okay, row 4. Row 4 is minus, okay, is minus these numbers. 0 minus 0, 0. Minus 2 minus minus plus 2, 0. Minus 5 minus minus plus 2, minus 5 plus 2, minus 3. Minus 1 minus 2, minus 3, right? Minus 3. Minus 15 minus 0, minus 15. Now, after step 3, we get this new augmented matrix, right? But are we done? Are we done here? Is it the coefficient part? The coefficient matrix looks like a strict triangle form. It's not, right? It's not. We need to make this A43, this one becomes 0. So we will choose this one as the pivot row, right? Pivot row. This is the new pivot row. And this minus 3 becomes the new pivot, right? Pivot. And why you cannot still go back to choose the first and the second row as your pivot row? Because if you go back, you cannot keep those 0 because those are non-zero. If you do the row operation, for example, multiple by 3, then you will get non-zero entries here. That's why we get the same row when they have the first two are the same zeros. Make sense? If you still go back to the first one as a pivot row, you will make those non-zero entry, those 0 entry becomes non-zero again, which means you work far from the strict triangular form, right? So that's why we go one by one for the pivot row. And then the row operation again, So here I use the blue color to write the row operations as the step, and I use the purple color to point out the pivot row and pivot, and some green yellow color to do some simple calculations. Okay. So we are going to replace row 4. So will be row 4. It's easy, right? Row 4 minus row 3. Because here is minus 3, right? So this one is easy. We will replace, so it will be row 4. This is like row 4 minus 1 times row 3, okay? 1 times row 3. Now let's write the new augmented matrix, okay? The new augmented matrix. We will keep the first 3 rows, okay? We will keep the first 3 rows. 1, 1, 1, 1, 6. And then second one 0 minus 1 minus 1 1 0 0 0 minus 3 minus 2 minus 13. So the last one, okay, the last one 0 minus 0. That's why we have 0, because we can still keep it 0. 0 minus 0, 0 minus 0, minus 3 plus 3, minus 3 plus 2, minus 15 plus 13, right? So we get this one. Now, are we done yet? What is the form of this coefficient matrix? Strict triangular form, right? Strict triangular form. So we can come back. We can come back to the coefficient matrix, and we know this is x1 first column, second column x2 third column, right? And this right side gives bi's, right? All the bi's. Okay, let me use a new page. Okay, I will write this matrix again. So let me show you the strict triangular matrix, and then we convert it into, we rewrite it as a system, as a linear system. This is 0 again. So continue. Okay, continue. Then the matrix is, can I repeat it again? So do you want me delay 20 minutes? Ask specific question, okay? Or I record the video for today and you replay the video, okay? You replay the video and then ask me questions after you watch the video. Let me rewrite the strict triangle form. And as I said again, if you mess up one number in the augmented matrix, your solution is different. Your solution is wrong. Okay, so be careful of those simple calculations in each step. So we can rewrite this one as a linear system, right? As a linear system. x1 plus x2 plus x3 plus x4 equals 6. That is the first equation, which corresponds to the first row. And then the second row, minus x2 minus x3 plus x4 equal to 0. And then the third equation, minus 3x3 minus 2x4 equals minus 13. And then minus x4 equals minus 2. Now let's solve it. Okay, back substitution. x4, 2, right? x4 is 2. Then go back. Minus 3x3 minus 2 times 2 equals minus 13. So we solve x3 is minus 9 over minus 3, which is 3, right? Then go back to the second equation, minus x2 minus x3 3 plus 4 plus 2 equal to 0. x2 equals minus 1. And then go back to the first equation, x1 plus x2 plus x3 plus x4 equals 6, right? Equals 6. So x1 is 3. Any mistake? Any calculation mistake? Oh, this is, hold on. X2 is minus what? Sorry. The last equation. Where? I delete? Oh my god. I delete all the stuff. Let me write a little quick. Sorry about it. So let me just write the equation, okay? Let me just write the equation. So according to the strict triangle form, we get the system, okay? We get the system. That is the first equation. First row, 1, 1, 1, 1, 1, 6. Second one, minus x2 minus x3 plus x4 equal to 0. And then minus 3x3 minus 2x4 equals minus 13. And minus x4 equals minus 2. So we solve x4 is 2, x3 is 3, right? and then x2 is minus 1, right? So my x1 will be 6 minus the sum of all those, right? The sum of all those is 4, which is 2, right? Which is 2. So the solution for this 3 by 3 system, that will be by order, okay? 2 minus 1, 3, 2, right? Now, if we go back, okay? If we go back, for those step 1, 2, 3, 4, those are all the row operations, okay? Those are all called row operations. Interchange, row 1, row 2, that is row operation type 1, right? Row operation type 1. And then this step 2, that is the replace the row by the row sum with a multiple of another row. Another row is the pivot row, right? Here, row 1 is the pivot row. And then this is also row operation type 3, okay? And this is the row operation type 3 also, okay? Also. So finally, we transform the original augmented matrix into a strict triangle form. Strict triangle form is based on the coefficient matrix part, right? We understand the vertical line. The left side of the vertical line gives the coefficient matrix. The right part is the constant bi, right? So in this way, we can solve the n by n system, okay? N by n system. And this is the strict triangle form. Next time, we will discuss a more restricted form called row echelon form, okay? That will be much easier or much simpler than strict triangle form. So we are trying to transform the original augmented matrix in that way, in the row echelon form. That will be much easier to solve the linear system, okay? It's almost time, okay? It's almost time. If we didn't interchange row 1, row 2, then, I mean, you need to decide your pivot row, okay? You need to decide your pivot row. So you need a non-zero pivot. You have to change. What do you mean if we didn't change? We are trying to perform the row operation to reach the strict triangle form. Without those procedures, those are more systematic way, okay? So if you use your high school knowledge to solve it, it's a little messy, okay? You will mess up everything, okay? You will rewrite my x2 equals x3 plus x4 and then go back to those. Then it's also a lot of work of calculation, right? And this is more systematically, and we need the matrix, okay? We need the matrix to solve the linear system, okay? And last time another engineering class, someone asked, if we get the answer why we need the row operations, why we need the matrix, then I said, without the matrix you cannot solve 5 by 5 system. How can you get your solutions? You can only solve with your high school knowledge for 2 by 2, 3 by 3 system. If it's 100 by 100 system, how can you solve it? We can make the computer, okay? We can make the computer follow this method to solve the system, okay? To solve the 100 by 100 or more complicated linear system. So we can coding, okay? We can write the algorithm and the coding for those methods, okay? For those methods. So that's why. And that is for section 1, okay? Section 1. We will stop here today.